Hi everyone, today we're going to talk about section 4.5 and we're actually going to cover two parts in this section and then we'll save the remaining other two parts for the next video or the next section of notes. So today I want to introduce to you how we are going to officially graph sine and cosine, and we're going to go off of information that we actually already know. We're going to use the unit circle to our advantage today, so it's extra practice. If you need that unit circle handy, go ahead and take it out and make sure you know it or you have it with you so that we can go through this. All right, so to get started, before we go through all the properties of the graph, let's just go ahead and graph the things that we know. So we have our typical XY coordinate here, and it's already labeled for us. Our highest Y value is 1 and our lowest Y value is -1. And then all of those X values, we'll call them thetas. All of those thetas are marked on the X-axis for us. We got positive and negative pi over 2, positive and negative pi, positive and negative 3 pi over 2, and positive and negative 2 pi. All of which are straight from the unit circle. So what I want to do is I want to start with 0. Start with the origin first. So if I were to ask what sine is at 0 degrees or 0 radians, you guys would look at your unit circle really quick, or you would remember that at 0 radians your sine is going to be 0. So I'm going to put a point at 0. And then I'm going to move to the right. So I'm going to move to the next section where it says pi over half, or pi over 2. So at the next section, next radian, sine of pi over 2, look at my unit circle, or I go ahead and remember, well, sine at pi over 2 is going to be a positive 1, and I can put my point there. Continue with the pattern, moving on to pi. Well, sine at pi is going to be a 0. Remember, sine is representing your Y value through this, so you're always checking the Y coordinate on your unit circle. 3 pi over 2, well, at sine at 3 pi over 2, it's not going to be positive 1, it's now going to be a -1. And last but not least, sine at 2 pi, once you complete the full circle, you will be at 0 again. So when I look at this right-hand side, if I go to trace out my dots here, you're going to kind of get like these loop-de-loops here, and they're going to go on forever. And what this is called is it's called a period. It's meaning that it's going to repeat this pattern, this period, every single 2 pi. So if I know that information, I can actually now work backwards. So if I want to continue this little snake-like pattern, if I go from the origin and now move to the left side, then at negative pi halves, I want it at -1. At negative pi, I'm back up to 0. Negative 3 pi halves, I'm back up to positive 1. And at negative 2 pi, I am back at 0 again. And if I connect the dots, you will see that the snake will get to continue. And it's the same pattern from each section. If I were to split this graph in half right here, down the y-axis, I know that the left side is going to be symmetrical. It's going to be the exact same on the right side. And the reason I know that is because the period of a sine function, a normal sine function with no changes whatsoever, is going to be 2 pi, and that is mentioned down below. So some properties based off of this graph. That's where we're going to get all of the following information. It says that our period is 2 pi, which again tells us that it's going to repeat after 2 pi length. So that's what a period is talking about. Repeat after 2 pi length. The domain, remember domain is your x values, so if you look from left to right, well, you can choose as many x values to the left and you can choose as many x values to the right, so that means our domain is going to be -infinity to +infinity. That was discussed in in unit 1 as well as unit 2 we talked about this semester. Your range is your y values, so if you take a look at your graph and you compare top to bottom, your lowest y value that you can ever have was -1, and your highest y value you could ever have was a +1. And be clear that these have brackets around them. because they could indeed equal both negative and positive 1 at any point in time. The second part is your x-intercept. And if you look at this graph, you notice that you have multiple x-intercepts. And yes, you can write out exactly every single one that's occurring, but the trick there is it's going to keep happening. Remember, there's arrows at either side of that graph, which means the pattern's going to keep going on and on and on and on forever. So instead of writing every single value in which you are going to have an x-intercept, what they have done is put pi times n, and they are calling n an integer, whatever number that's going to be. So what this is essentially standing for is it's saying that every pi there is an x-intercept. That's essentially what pi n stands for. It could be n number of times, but at every single pi, there will be an x-intercept. So that takes care of every single thing to the left and every single x-intercept to the right. That's what that means. So that instead of writing out every single one and going on and on forever and ever, you just get it by saying n with it. That takes care of that. Then your y-intercept, well, if you look at your graph, your y-intercept is going to be at 0. That's the only time it's going to cross the y-axis. And it's just looking for the y value at that point. And then our max and min values. So as you look through this graph, you will see that there's a lot of maximums and there's a lot of minimums. And in fact, there's actually it's actually a pattern. What I should say is it is a pattern. So if you look at all your maximums at all the highest points of this graph, we have the highest point at negative 3 pi over 2, as well as the highest point of pi over 2. And there's going to be patterns to this. So if you look closely at what's written already, it says your max value is always going to be at 1, which you can tell your y value will always be at 1. That's the maximum. And it's going to occur when x equals pi over 2 plus every single period after that. So that's how the period is going to reflect back in to our max and min values. So our period was 2 pi, and then we're bringing that n back into play to say that it occurs every n times. All right. And for right now, when it says even pi, odd pi, just ignore that for now. It will come up later on. But for right now, what I want you to pay attention to is that this 2 pi n is telling you that it's going to repeat every 2 pi n times. We don't know how many times it's going to repeat because there's infinitely many times it's going to occur. So we're going to throw an n on that to signal that that is every n times. Similarly, for your minimum value, again, you'll notice that the pi over 2 from our max was taken from the right side of the graph. Same thing for the minimum. The 3 pi over 2 was taken from the minimum side on the right-hand side of the graph. So you can stick with that. Don't worry about the negatives because, of course, if n were a negative number, meaning you're going to the left, then it will be taken care of as such. So that's where that n comes into play again. So your minimum value this time, the lowest point on the graph is going to be at negative 1 for your y value. And then that is going to occur when x equals 3 pi over 2 plus every single pi, or every single period, after that. And our period, of course, was 2 pi, but we have to put an n with it as it will keep occurring over and over from there. So that is our sine graph. Now we're going to go ahead and do our cosine graph, and they're going to differ a little bit, but it's the same kind of idea. So let's start at the origin. Let's start at 0. And if I asked you what cosine at 0 radians was going to be, you're going to look at your unit circle. And this time, your cosine at 0 is going to be a positive 1. Moving to the right, if I were to ask you what cosine was at pi over 2, you would then tell me that it was 0. Following the pattern, cosine at pi is going to be a -1. Remember, cosine is your x coordinate as you're looking through it. Cosine at 3 pi over 2, back to 0. And cosine at 2 pi is back at 1. So we're taking care of just this right-hand side first. And I want you to pay attention to the patterns. So again, you're kind of doing this loop-de-loop again. All right, and what I want you to notice is when you go to 2 pi, it's going to come back down again. And so by knowing that it's going to come back down again, you are essentially repeating this section of your graph. And when you start to repeat, that's when we know the period of our function. So again, the period of a cosine function is also going to be 2 pi. You have gone a full circle. Now, this is just the period of a normal cosine, just like a normal sine before. There's been no changes whatsoever. We will talk about changes. That is the 2 section of notes we're going to cover today, and then 2 more sections next class. So, right now, this is your standard version of a sine and a cosine function with no other changes. So their periods are going to be 2 pi. So now let's work backwards. If I wanted to keep this pattern going, then that means at negative pi over 2, it's got to be 0. At negative pi, it's got to be a -1. At negative 3 pi over 2, it's back to 0. And at negative 2 pi, we are up to positive 1. So if I go to connect my dots this time, of course you're rounding it a little bit better than I just did, it's going to look something like this. So that is the graph of a cosine function. And now we will go through the properties based off of what we see from this graph. So again, we notice that 2 pi represents the period in which it's going to repeat. So we can write that in again, that this is where it's going to repeat after 2 pi length. And repeating just means the graph is going to just start all over again, but at a different point. But it's the same pattern, it's the same shape throughout. Your domain of this graph, well, according to those arrows, they're telling you that you're going all the way to the left and all the way to the right the entire time. So that means that your x values are going to be any number between -infinity and +infinity because there's no restriction. It's never going to stop. That pattern will continue forever and ever and ever. As for your range, it's the same idea. Your y values. Well, what's the lowest y value? And then what's the highest y value? So the lowest was -1, while the highest was +1. And again, please notice that there are brackets on those values yet again, because it could equal those exact numbers. As for your x-intercepts, try this one on your own. Take a look at the first x-intercept that's going to occur on the right-hand side. Always work with positives because that's easier. So it's going to occur the first time at pi over 2. And then the next time it's going to occur is at 3 pi over 2. So if you take a look at how that happened or what you had to add to pi, or add to pi over 2 to get to 3 pi over 2, you essentially had to add another pi. So that's how they got this pi here. They told you, well, you took your first x-intercept, and in order to get to that second x-intercept, we had to add another pi over to get 3 pi over 2. Essentially, what you did was you took pi over 2, and you added pi, but of course, you have fractions, so you need the same denominators, which is going to change it into a 2 pi over 2. And when you finally add them together, you got your 3 pi over 2. So that is confirming that you did indeed just add pi to get your next x-intercept. And one more time, you're adding that n to it, you're multiplying that n in so that you can remind yourself that this is going to occur every pi n times. That's going to take everything to the right of the origin for your x-intercepts, as well as taking everything to the left side of the origin for your x-intercepts. That n takes care of all of that for you. Your y-intercept, well, the only time you're going to cross the y-axis is at 1. If you take a look at the graph, you're only crossing at 1. Your max value, well, I want you to take a look at the maximum that it occurs at. So the max that this one is going to occur at is going to be at x is 0 for your y-intercept. It's going to be up here. That is your maximum. And then the next time that maximum is going to occur is at 2 pi. All right. Now, one way I would write this, as opposed to what's written on this paper here, is it says it's going to occur when x equals pi times n. And they were very specific on this n. They told you that n has to be an even integer. And if you think of your even numbers, it goes 2, 4, 6, 8. Well, that makes sense because the next n value that this was going to occur was at 2 pi. So by having that restriction, you are keeping in mind that it's only occurring every even time you're on your cosine graph. All right, now another way you could write that, instead of saying x equals pi n when n is just an even integer, make sure it just maybe says x equals 2 pi, and then you can bring in that n. That way it doesn't necessarily matter if n happens to be positive or it happens to be even or odd, because it will be taken care of. Similarly, for the second piece, for your minimum value, I would say your minimum value is when y equals -1, and that will occur if you take a look at your first minimum value, that's at pi. It's going to occur at every pi, and then from there it will occur from every 2 pi after that. So instead of saying this odd integer portion, I might say, well, x is going to happen on your minimum value at every pi plus every 2 pi n after that. So start with what it starts at, and then add your period after that. So if I go back to the maximum value, I wasn't very specific on this one, but it would technically start at 0, and then I would add every 2 pi n after that. So because it was 0, I didn't necessarily have to include that on my x-intercept, or excuse me, on my max value for my x's, but of course you can if you need to. So start with where it begins at your max value, and then add your period after that. So it's very similar to the sine. I don't want you to get confused with this even integer and odd integer stuff. That does get kind of confusing and very technical. So that was just an overview of what sine and cosine graphs will look like. Now we're going to talk about their transitions. So the first section of notes is going to tell us about what's called our amplitude. And we're going to talk about our amplitude for both sine and cosine functions. So our amplitude is going to be represented by the letter A, and it's always going to be the absolute value of A. So whether our A value is positive or negative, our amplitude value will always be the positive version. All right, that's why we take the absolute value. And what the amplitude is going to tell us is it's going to tell us the height from the middle of our graph. And if you remember from the two graphs we just graphed, the height, or excuse me, the middle of your graph was on the x-axis every time. And then the height from the top to the middle was 1, and the height from the bottom to the middle was also 1. Okay? We want to say 1 and not -1 because we are taking the absolute value of that. So we're going to get some practice. On question 1, we are given the function y equals 3 sine of x. So before we even get started, I want you to identify our only letter that we know so far. We know that A, our amplitude in the front of the function, has to equal 3. Well, because that's my amplitude, I know that that means my maximum is going to have to equal 3. And then my minimum, talking about the lowest point, is going to have to be a -3. With that bit of information, let's go ahead and make a little picture. So I'm going to have my x and y, much like the two graphs we just did previously. Okay, give yourself plenty of space on that x-axis. We know that the highest height is going to be 3, so I'm going to mark up 3 spaces. And the lowest height is going to be -3, so I'm going to mark down 3 spaces. Remembering the sections of sine that we know, don't worry about those weird fractions like 1/2 or square root of 2/2 or square root of 3/2. All right, let's work with the ones and zeros. Those are much, much easier to know. So if I think of my unit circle, well, at 0 degrees, sine will have a nice value. The next nice value that sine will have is at pi/2. And I'm talking nice values like zeros and ones. I'm looking to see on my unit circle where sine can be 0 or sine can be 1. Following that, it will be at pi. Then 3pi/2, followed by 2pi. Ironically enough, if you take a look at that right-hand side, that's going to remind us that our period for a sine function is going to be 2pi. I'll show you how to use periods here in the next section of notes. So now I can go through and I'm just going to fill in the right side and I'll mimic the same thing on the left side. So it's 0. Let's start with 0. That's easy. Sine at 0 is going to be 0. So there's my first point. Sine at pi/2 is going to equal 1. But remember, we have this 3 out front now, so that's now going to tell us we need to take 3, multiply that with 1. So I know that sine of pi/2 is going to be a +3 this time. That amplitude is now going to take my function and raise it up 3 on my height. Going back to pi, that is now asking us, what is 3 times sine at pi? Take a look at your unit circle. Well, at pi, your sine is 0. So now what is 3 times 0? And we are at 0. Okay, you can use your calculators if you need to. You can use the unit circle if you need to. In fact, I highly recommend it. But now we are talking about this 3 that happens to be in front. So it's going to play a role on our graph this time. So I'm going to do the next one, 3pi/2, and I'm now asking, well, what is my y value when 3 times sine at 3pi/2? Take a look at the unit circle. Well, it's sine at 3pi/2 is going to be -1, and we have this 3 still out front, so now my y value for this function is going to be -3. Same thing with 2pi. What is my y value with 3 times sine at 2pi? Well, sine at 2pi is going to be 0. Keep that 3 out front. You know you're multiplying. So 3 times 0 is going to give me 0. So you'll notice if you take a look at the first graph we did at the very beginning of these notes, compared to this graph, they're the exact same points, except now instead of ones and -1s, I'm going to have a 3 and a -3. So I go ahead and I make my lines and of course draw arrows to signal that you're going to keep going. Now this is only one period. If I wanted to graph 2 periods, I would do it on the left-hand side. So that means I want to go backwards. I'm going to go back -pi/2, back -pi, back -3pi/2, and back -2pi. Well, if I know what it has to look like on the right side, I can mimic the exact same thing on the left side. So the furthest left point's got to be at 0, followed by the next point that's got to be up at 3, negative pi has to have 0, and negative pi over 2 has to be negative 3. And notice that the pattern will continue. So you have your graph. You have both the right side and the left side. So now let's talk about the properties of this function. And the main properties I'm concerned about is our y-intercept, my x-intercept, my domain, and my range. And it's all based off of this graph that we just did. So my y-intercept, take a look at where you're crossing the y-axis. I only want the y value at that coordinate, so my y-intercept is going to be 0. Your x-intercept, again, start with what we know, and then we will add more over. So my first x-intercept is going to cross right at the origin. So I'm going to say my x-intercept is 0, and then my next x-intercept, because there are more than one, is going to occur at pi. And if I continue the pattern, then the next one would occur at 2 pi. So I'm going to say, well, it's adding a pi every single time, so I'm going to put an n with that. So my x-intercepts are always going to occur at 0 plus pi times n. Or, of course, if you want to say just pi n, that is fine as well. So you can get rid of that 0. Start with what you know, and then add more based off of the graph, since there are multiple x-intercepts on that function. Our domain, remember, domain is your x values from left to right. It's going to repeat itself over and over again. You'll notice the pattern. Your domain is always going to be negative infinity to positive infinity, because those arrows are signaling that it's going to keep going to the left and always keep going to the right. Those are your x values. Your range, your highest to lowest portions, or your lowest to highest, that's the order in which we want to go. Your lowest y value is going to be negative 3, while your highest y value is going to be positive 3. And then we want to put brackets around those. So if you were to take a look at this first number, or this first question, I want you to relate that your amplitude is always going to play a role with your range. All right, that's one thing to keep in mind as we go through. So I'm going to go ahead and do question 2, which is our cosine now. Cosine with an amplitude, your a value in the very, very front is going to be 1/2. Well, if my amplitude is 1/2, then that tells me that my maximum is going to occur at 1/2, while my minimum will be at negative 1/2. Okay, let's draw a picture. Remember that on a cosine graph with no other shifts, besides amplitude, of course, your period is going to be at 2 pi. So as we develop this graph every single time and try to figure out those easy coordinates that we know on the unit circle, I want you to take your period and I want you to divide it by 4 so that we can get 4 points to the right, and then we'll follow with the same 4 points on the left side. So if I simplify this, that is going to tell me that I want to have a nice coordinate every single pi halves. So when I look at my graph, the first coordinate that's going to happen is going to be at pi halves. If I move another pi halves, that's going to put me at pi. Half times a half puts me at 1. And then we're talking about pi, so it's going to be half of a pi gives me 1 pi. The next half of a pi is going to be 3 pi over 2. And the following half of a pi will give me 4 pi over 2, which is just 2 pi. So the only reason I'm showing this now is so that it will help us later, okay? The periods help determine what my 4 points on this graph are going to be, going to the right as well as to the left. So if I know the right ones, let's get the left ones out of the way as well. It's going to be the exact same for just the negative versions, not over 4. I say 4 and I want to write 4. All right. Well, now let's label our y values. Well, the highest y value that we know we're going to have is based off of our amplitudes. So the highest is going to be positive 1/2, while the lowest is going to be negative 1/2. Do I need to mark these and label these? Yes, you do. All right, it is important. So let's go ahead and make our function. Start with 0. Well, if I plugged in a 0 for my x this time, I know that my cosine at 0 is going to be 1, but now I have to multiply that by 1/2. So my cosine at 0 is going to be positive 1/2. Moving to pi over 2, well, 1/2 cosine at pi over 2. Pi over 2 for cosine is going to be 0 times 1/2, so I got 0. You'll start to see the patterns. Cosine, or y equals 1/2 cosine at pi. Well, you know cosine at pi is now negative 1 times 1/2. That puts us at negative 1/2. 3 pi over 2, cosine of 3 pi over 2 is going to give us 0. 0 times 1/2 is still 0. Cosine at 2 pi is a positive 1. Positive 1 times 1/2 is going to be 1/2. And there we have it, the right side of our graph. And if I want the same thing on the left side, I'm just going to repeat the pattern. And we will have our full graph. But of course, it's continuing all the way to the left and all the way to the right. And I'm going to ask you for the same 4 things: your y-intercept, your x-intercept, your domain, and your range, based off of the graph that we just did. Y-intercept, well, the point in which you cross the y-axis is going to be at 1/2. Your x-intercept, well, the first time you crossed the x-axis was at pi over 2. And then from there, you went from pi over 2 to 3 pi over 2. So when you think about how much you added a full pi, and that pattern will continue n more times. So pi over 2 plus pi n. Domain, x values from left to right. So your x values are negative infinity to positive infinity. And then our range again, remember the amplitude helps us with our range. It's going to go from negative 1/2 to positive 1/2. And there you have it. All right. So there are 2 more questions to go with this. And I want you guys to practice that on your own. All right. I won't put this in the notes for the video, but they are posted on Teams for my teacher notes, so you can always go there and practice. I want to now go into section B, where we talk about the letter B and how that is going to affect our graph. So for questions 3 and 4, do these on your own. And then you can check my team's notes for the answers to check your work. And of course, if something's wrong or you have a question, please let me know. Do questions 3 and 4 on your own for sign. The last section for today is going to be 4.5 with the letter B. All right. That B is going to represent our period. We talked about period already for sine and cosine graphs, but the repetition of our graphs can vary depending on the letter B. So whether it's a cosine or a sine graph, take a look at where B is going to fall. We still have our amplitude in the front here, that's our A. And then we're going to introduce the capital letter B. All right, so things to remember. A is amplitude, while B is going to tell me my period, but there's a function we have to use in order to find the period. So that's where that 2 pi over B has to occur. So the letter B doesn't perfectly tell me the period, the repetition. I have to do a little bit of math to find that repetition. All right, so here's how it's going to work. We're going to start off by identifying the 2 letters we know so far, my A and my B. So for question 1, I want you to say that, well, letter A, my amplitude, the number in front, has to be a 3. Keeping that in mind, that tells me that my maximum for this graph is going to be at 3, while my minimum for this graph is going to be at -3. And then when I get to the letter B, I know that B is the number 2. All right, well, that can't do much for me quite yet because now I need to do the period based off of this information. So period is always 2 pi divided by my B value, which was 2. And when I simplify this, I'm going to get pi. And what that means is that every time I go pi length on my graph, I'm going to repeat the cycle. So period is always repeating. So I have every pi length, your graph is going to repeat. So the only periods we've seen so far is 2 pi. Every 2 pi, my period repeats. So if you were to think of a graph and you think 2 pi, well, 2 pi is going to be kind of wider. And as soon as you say now that your pi is your period, you are taking that repetition and you are squeezing it together horizontally. So now it's going to repeat even skinnier, essentially. And we're going to prove that with our graphs. All right. So let's go ahead and make our XY axes. And what I said earlier is now we have to determine those 4 points on the right-hand side of this graph. We can't necessarily use pi over 2 and pi and 3 pi over 2 and 2 pi. We can, but we're going to end up getting some decimals throughout this because as I do that, I'm going to have to factor in that 2 when I do my math, when I introduce those pi over 2s and those pi's and 3 pi over 2s and what have you. So there's a trick, and I've already talked about this trick, but we're going to make it more clear here. Take a look at your period that we just found. Well, my period was pi. I'm going to take that pi, and I'm now going to divide it by 4 so that I can get a nice 4 sections on my graph. Well, I don't have to simplify that. All this is now telling me is that pi fourths are going to be nice sections to make on my picture. Okay, so every pi fourths, I want to put a point on my x-axis. So if I go 4 points to the right, I'm going to have pi over 4 as my first one. The next pi over 4 is going to give me a 2 pi over 4, which will simplify to pi halves. The next pi over 4 will give me 3 pi over 4, followed by, what do you know, 4 pi over 4, which is a nice pi. So everything on that right-hand side now is going to be condensed into your period. You're going to have a full section, a full cycle of this cosine picture, or of this sine picture. Now let's do the same thing on the left-hand side. negative pi over 4, negative 3 pi, or nope, not 3 pi, negative pi over 2, negative 3 pi over 2, excuse me, over 4, sorry guys, and then negative pi. Think back to your amplitude now. Let's do my y's. Well, the highest y value we can have is 3. The lowest y value we can have is negative 3. And now when I go to determine my function, or my answers, my coordinates, I'm going to start by plugging in a 0. So what that tells me is I'm going to find my y value of the function 3 sine 2, and I have to now introduce 0 radians for my x. So I have to do that 2 times 0 first before I can find the sine at that value. So now I have to say, well, what is sine at 0 radians? And now that I multiplied that 2 and 0 together, it gave me 0. So now I look at the unit circle and I find sine at 0, which is going to be 0. So at this picture, at 0 on my x, I want a y value that's also 0. Follow the pattern. Do this next point. What is my y value at 3 sine of 2 times pi over 4? Well, simplify this first before you look at your unit circle. 2 times pi over 4 is going to give me 2 pi over 4, which will now simplify to pi over 2. And now I say, well, what is what is sine at pi over 2? Well, that's going to give me a 1. Now, that doesn't mean that at pi over 2, you're going to put a point at 3. No way, okay? That was not the point you just tested. You just tested pi over 4. And it got you a pi over 2 because of that number 2, that b value in front. So that's still going to be the coordinate for pi over 4. Follow with pi halves now. Well, what is your sine? Your 3 sine 2 at pi halves. Multiply those together, and now you're looking at sine at pi. And sine at pi is going to be 0 again. So you're going to have to do a little bit of math here, okay? This 2 is going to have to be multiplied by the x value you are trying to find. And if you continue with 3 pi over 4, that's going to give you 3 pi halves. Well, sine at 3 pi halves is negative 1 times 3 gives us negative 3. When you're looking for pi, 2 times pi gives you 2 pi. Sine at 2 pi is going to give you 0. Well, 3 times 0 gives me 0. So here is the right side of my picture. You can do the same thing on the left-hand side. Do a quick sketch here. That's going to take me down, loop around, and there we have it. Okay. You have graphed essentially not just one period of this function, but 2 periods, because you've graphed 2 repetitive cycles of this function. Now that we have our graph, let's identify the same 4 things. What's my y-intercept, my x-intercept, and my domain, and range. All right. Y-intercept, well, what's your y value when you cross the y-axis? That is 0. X-intercept, well, at 0 is where you're starting. The next intercept is going to occur at pi halves, and it's going to keep repeating every n times. Start with what you know, add the next one, and throw an n on it, essentially. Domain from left to right, negative infinity to infinity. You have every single x value you can imagine from left to right. And your range, remember, range is always your amplitude, so we don't have to worry about that 2 for our b value at all. We just need to know that my lowest value was at -3, while my highest value was at +3. And then make sure you put brackets on those for your range. Okay? This is a lot of information, I'm not going to lie. But it's going to be one of those things that we just need to practice. All right. As we get through this, we won't need to make these graphs any longer. The graphs are just helping us determine the end results, the final properties of that function. All right. So by the end of this, we shouldn't need to graph every single thing. We will get to see and get to remember, well, this is what happens when A is 3. This is what happens when B is 2. And off of all of that information, we will know how to make our properties. So I'm going to do question 2, and again, I'll assign 3 and 4 for you guys to try and look at my notes again. So for question 2, same thing, identify your A value. Your A value is technically a -3, but at the end of the day, we know it's really the absolute value of -3, which is +3. That tells me that my max is going to be a +3, while my minimum is at -3. Okay. Then we'll identify our B value. Well, our B value here, if x were to be brought down right here next to it, what number is really in front of that x? It's the number 1. So without the x, again, the b is just the number in front of x. So my b value this time is going to be 1/2. Now that we know our b, let's identify my period. Period is always the function 2 pi over my b value, which we just found was 1/2. Well, you have a fraction divided by a fraction. This is technically, if I were to rewrite it, it's technically 2 pi over 1 divided by 1/2. So I want to skip the first fraction, flip the second, and then I want to multiply. And remember, when we multiply, we are multiplying straight with each piece. So my period for this one is going to be 4 pi. It's going to repeat itself every 4th pi. So, if I go to make my graph this time, I just want to stay with positives, okay? You'll notice on my teacher notes, I kind of go back and forth between doing left sides and right sides. It doesn't matter. I'm just looking for 2 cycles, 2 periods. So if you want to do the left side and you know it's the same values, just the negative versions, that's fine. But I'm going to show you why or how I'm doing the right side. And it's the same idea. I'm just going to keep the pattern continuing, essentially. So I'm going to graph just the right side of my quadrants. I'm going to take my period that was 4 pi. Going to do that trick that says I'm going to divide it by 4 so that I can find nice 4 numbers on my graph. And that tells me I want it to occur every pi values. So every pi, this is what this is saying, every pi has a value on my graph for x. So now when I go to my function, when I go to my graph, my first portion is going to be 1 pi. The next one's going to be 2 pi because I'm going every pi now. Followed by 3 pi, 4 pi. So that's a full cycle right there. That's my period. And now I'm going to do another cycle that continues on to the right side. And before I would have done a cycle that continues on to the left side. It doesn't matter. I just noticed that these are really nice values to work with as I'm just counting by ones essentially each time. So the next one would end at 8 pi. Then I'm going to label my y values. Well, my highest y value for this one's going to be 3. while my lowest y value is going to be -3. And then we're going to start with what we know. So I'm going to use 0 first. Don't ever forget about 0. It's one of the nicest values we can use. So I'm going to plug 0 in for x. So I'm saying, well, what is y equals -3 cosine of 0/2? Fix that fraction really quick, and I'm really asking, well, what is cosine at 0 radians? Cosine at 0 radians is a +1, so right off the bat, at 0 for my x, I want to be at -3 on my y. Then I'm going to do pi. Well, y equals -3 cosine of pi/2. That's asking me, well, what is cosine at pi/2? Well, that's going to be 0. So now my function is just 0. So my next point is at 0 for pi. Plug in a 2 pi next. Don't forget the original 2, it's down below. That's really asking, well, what is cosine at pi? Well, cosine at pi is -1 with that -3 out front, so I'm asking, or I'm finding that my y is now going to be a +3. Put a point. I can keep doing this if I don't see the pattern quite yet, that is fine. Cosine at 3 pi divided by 2. Well, cosine at 3 pi/2 is going to be 0. So my point will be at 0 on 3 pi. And then for the last one, that's where my period is going to end. I'm saying, well, what is y when x is 4 pi? Which is essentially saying, well, what is -3 cosine at 2 pi? Cosine at 2 pi is just 1. Therefore, my value, my coordinate, is at -3 when I do my 4 pi. And I can go ahead and make my graph. And it's going to keep going. And in fact, it's going to keep going. At 5 pi, it will be 0. At 6 pi, it'll be 3. At 7 pi, it'll be 0. And at 8 pi, it will be -3. So I can take that arrow and keep finding the next cycle. And it will keep going over and over and over again. So we're going to answer the same 4 questions. What's my y-intercept? What's my x-intercept? My domain, and my range. Y-intercept, well, where do you cross the y-axis? You're crossing at -3 on this one. Your first x-intercept is going to occur at pi, followed by the next x-intercept, which was at 3 pi. So what did you add to that to get to 3 pi? You added a 2 pi. And that's going to happen, that's going to happen every n times after that. So that is your x-intercept, pi plus 2 pi n. Domain is going to be -infinity to +infinity. It will always be that. And your range is your amplitude going from -3 to +3. And there you have it. You have your 4 bits of information. Right? So I'm going to make questions 3 and 4, again, something you try on your own. You have this on my teacher document, my teacher notes, posted on Teams. If you like to just work on the left and right side and keep the same coordinates on the left as you have on the right, that is fine. My teacher notes do talk about just the right side of my graph. It's the same idea. I just want you guys to practice getting some repetitions, getting those periods graphed. All right. Whether you like to keep that repetition on the right side or bring it back to the left side is totally up to you. We know it's going to continue forever and ever and ever, so you stick with whatever repetitions you prefer. That is fine.